Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, my dear wonderful students. I want to welcome you to yet another 30-minute session of wonderful TV learning, and I hope you are excited to join me today again. I am your teacher for physics. My name is Teacher JB, and I hope you remember me. And today, we are going to be learning physics together with the students of Senior 3 and any other student who may want to join us to learn physics. Last time, if you remember, we were here and we were learning about latent heat, and today we want to just pick on from latent heat and move on to the next item that we are going to reveal very soon. And so, if you will move with me either to the blackboard here, okay, or to our screen, I want to introduce to you our topic of discussion during today's lesson. Okay, so we are still on unit number 5, as you can see, and our lesson today is going to be about specific latent heat, okay? Last time we looked at latent heat, only this, but today we shall be looking at specific latent heat. That is what we want to look at today. And so, let's introduce our learning objectives today. What should we learn? What should we get at the end of this 30-minute session that we are going to have together? So, number 1, I want every one of you to be able to define specific latent heat of a substance. Okay? That is one thing that I want you to be able to do. Defining specific latent heat of a substance. Number 2, I want you to be able to derive and state the formula H equals ml or Q equals ml. We shall see what Q means and also what H means. But we must be able to do that. Then we should be able to state the SI unit and the SI unit of specific latent heat. So what is the standard unit of specific latent heat? Lastly, during this lesson, we should be able to use the formula. You see, this formula H equals ml or Q equals ml to solve numerical problems. So this is what we want to achieve during this lesson. Q equals ml, H equals ml. They mean the same thing, but we shall want to see how we can derive them and also use that equation. So that's what we want to do during today's lesson. Now, before we embark on today's lesson, there was a wonderful assignment that you remained with last time. Do you remember? Yes. There was a wonderful assignment that I left you with last time. You should remember. Now, one of the questions, part A, was asking, define latent heat. And we will move very quickly there because I believe it is very easy. Defining latent heat. Last time we said latent heat is the amount of heat required to change the state of a substance from one form to another at a constant temperature. That was quite very easy. Then 2, why does the temperature of a substance remain constant? Okay, I'm going to note down something small so you may be able to remember. During change of state, if you remember, we performed some experiments here where we heated some wax, we melted it. We melted lots of other substances, including crayon. You remember the crayons that we burnt here that melted? So we said, during change of state, the temperature remains constant. So we are asking, why does the temperature remain constant? Now, answer to part B is that the temperature remains constant because the heat energy absorbed is used to break the intermolecular force, or we can say forces of attraction. Okay? Intermolecular forces of attraction between the molecules. We can say molecules or between the atoms. So that is why even when the substance is absorbing heat, that heat does not manipulate itself in terms of increase in temperature, but rather it changes the state of the substance because that energy is used to break the intermolecular forces of attraction between the particles of the substance. I think that was maybe the most complicated number that I left you with. Otherwise, the rest are easy. Define the following processes of melting, deposition, sublimation, evaporation, condensation. These ones are quite very easy. Now, to just remind us, I will take you to this board. Are you able to see what is here? So here we have solid, liquid, and what? And gas. Now, process A is from solid to liquid. Now, process of changing from solid to liquid, remember we said, is melting. So it means where there is A, we can put melting. Or fusion, same thing. For B, B is the opposite of that. From liquid to solid, remember, we said is called freezing. And if you remember, in our presentation last time, in our discussion, we talked about all these processes. So I just want you to go ahead and remember, where do we put deposition, where do we put sublimation, evaporation, and condensation? That was quite very easy. We don't want to spend a lot of time on that. You already have it. Okay, let's move ahead. Now, as I told you, the main objectives of this lesson are to define specific latent heat. We also want to derive and state the formula H equals ml. So let's go straight to defining specific latent heat. Now, last time we defined latent heat, only this latent heat, without the word specific. And if you remember, I told you, specific refers to how many kilograms? 1 kilogram. In this case, 1 unit. So, specific latent heat is the amount of heat required by 1 kilogram of a substance to change its state or phase, okay, this word phase, at a constant temperature. You can also go ahead and add the word at standard atmospheric pressure, because that should happen at a standard atmospheric pressure. So I'm going to repeat this. I hope you are going to speak it with me as well. Specific latent heat is the amount of heat required by 1 kilogram of a substance to change its state at a constant temperature and standard atmospheric pressure. So that is the meaning of specific latent heat. We are going to come back to that very quickly, especially when we begin attaching figures to specific latent heat. But let's first go to the symbol. Now, the factors that affect the amount of heat absorbed during change of state, unlike for specific heat capacity, we shall see that the amount of heat absorbed by a substance that is changing its state is proportional to the mass only. So, amount of heat absorbed by any substance changing its state increases with increase in mass. So you have more mass, you need more heat to make a substance change its state. You also know when you're boiling water, if you need the water to change into vapor, if you have 1 liter of water, you need less energy. If you have 2 liters, you need more energy. So amount of heat is proportional to M. Some people do not like using H, they use Q. So we say Q is proportional to M, where M is mass and Q is quantity of heat. So if we remove the proportionality sign, we are going to introduce a constant, okay? we are going to introduce a constant, and we have talked about this before. So that is constant times m. So it means h is going to be equal to that constant, then times m. Now, the name of this constant, the symbol we use for this constant is L. And what is this constant? This constant is what we are referring to as specific latent heat. So I hope you see where we get specific latent heat from. Again, if you follow this, it will be Q is equal to mL, the same thing. Remember, Q and H can be used to represent quantity of heat. Now, let me go ahead and make L the subject here. If I make L the subject, I have to divide this side by M, the other side also by M. So L is going to be equal to Q, then over what? Over M. Remember, Q is quantity of heat. M is mass. So what are the units, therefore? The unit of quantity of heat is joules, because heat is energy, measured in joules. And M is mass, which is measured in what? In kilograms. And so what is the SI unit of a specific latent heat? The SI unit is going to be joules divided by what? By kilogram. And so if you come back with me here, that's why we are saying H or Q is amount of heat. Okay? M is mass, and L is specific latent heat. So SI unit of L is joule per kilogram. You can also write it as J stroke kg. That is joules per kilogram. We can also write it as J, then kg to power negative 1. Okay. I hope that is great so far. Let's come back here. Different substances have different specific latent heats. The values are different, because if you have ice, which is solid, and you want it to melt, it will not require the same amount of heat like wax, okay? They require different amounts of heat. So, for instance here, the specific heat latent heat of fusion of ice is 330,000 joules per kilogram. So, what does this statement mean? This is very important. This statement means that 330,000 joules of heat are required to melt how many kilograms of ice? 1 kilogram of ice at a standard pressure and at the melting point of ice, which is 0 degrees Celsius. I need you to get that nicely, so I'm going to clear off this part. This formula is right there on the board, so we can always look at it. So what I'm saying here is, if I have 330, right there, 330,000 joules of heat, this will be required to melt how many kilograms of ice? 1 kilogram of ice at 0 degrees Celsius. Remember, this 1 kilogram of ice is equal to how many grams? 1,000 grams. So sometimes they ask you, how many joules of heat are required for only 1 gram? You see? So 330,000 joules are required by 1 kilogram, which is 1,000 grams. What about only 1 gram? We divide this value by 1,000. We also divide this value by what? 1,000. So it means 330 joules will be required by how many grams? 1 gram. And that leads us to the next statement, which is specific latent heat of fusion of ice is equal to 330,000 joules for every what? Kilogram. But we can also state it as 330, this value, joules for every what? For every gram. That is what that statement means. And I need you to get that very nicely. Okay? You can get the specific heat capacity, specific latent heat in terms of joules per kilogram, but also in terms of joules per gram. Okay, I hope that is understood there. So let's go to an activity. Okay? And I need you to read that activity. See what is being asked. I'm going to clear off this part. I don't think we need it anymore, so that we can clear way for our activity. I need you to be reading the activity in the meantime, okay? Focus your attention on the activity. Focus your attention on the activity. So look at part A. Is part A easy? To me, it is quite very easy, because they are saying, define latent heat of fusion of ice. Okay? Latent heat of fusion of ice. So this is activity 1. So latent heat, specific latent heat of fusion. The only thing I'm seeing here is fusion. Because fusion means change of state from solid to what? Liquid. So let me tell it to you as you write. I think it is going to be easier for you. So specific latent heat is the amount of heat required by 1 kilogram of a substance, in this case ice, to change its state from solid to liquid at a constant temperature. I'm going to repeat. Specific latent heat of fusion of ice is the amount of heat required to change the state of ice from, the state of 1 kilogram of ice from solid to liquid at constant temperature. Let's go to specific latent heat of vaporization of water. This is the amount of heat required by 1 kilogram of water, okay? Required by 1 kilogram of water to change its state from liquid to gas at a constant temperature. So that is specific latent heat of vaporization of water. So I believe you have mastered those down. Let's go to C. C, we need to interpret it. The specific latent heat of fusion of substance X. Remember the symbol we use for specific latent heat? It is L. So specific latent heat is 11,000. 11,000 joules per what? Per kilogram. Okay? How much heat energy in joules does 1 gram of X require to melt it at its melting point? Do you remember something that we did here? This is in joules per kilogram. So if you want joules per gram, because that's what they're asking, 1 gram, we are going to see that the heat required by 1 gram is going to be 11,000 divided by what? By 1,000. So this cancels that. In that case, the amount of heat which is required by only 1 gram is going to be 11 joules. And that is what we talked about before. Okay? Let's move to activity number 2. Right. Activity number 2 is telling us to calculate the amount of heat energy required to convert 2.5 kilograms of ice at what temperature? 0 degrees Celsius to water at also 0 degrees Celsius. Remember, specific latent heat, no change in temperature. And they have given us specific latent heat of fusion of ice. Again, when you look at our table here, I was able to give you some specifics. Like here, this is specific latent heat of fusion of the following substances. Then this is melting point, MP. That's what it means. I didn't have enough space, so that's why I used those abbreviations. LV, specific latent heat of fusion, you see? Of vaporization. And then BP is boiling point. So if you look at like water, these are the specifics. Melting point of ice is 0, and the boiling point is 100, and so on and so forth. You don't need to cram those values, but they are important for us to know. We shall always be giving you. So when you go back to this, let's look at what is being asked. Okay? This is our activity number 2. So question number 1, let's look at what is being asked. They are telling us Calculate the amount of heat. Amount of heat, we represent it using letter H or letter Q. Me, I'm deciding to use H, but you can use Q. Okay? Required to convert 2.5 kilograms. So what is 2.5 kilograms? According to me, it is mass, 2.5 kilograms of ice. And they are giving us specific latent heat. That means LF as being equal to 330,000 joules per kilogram. Okay? We don't need to change anything. So what next do we do? We are going to state the formula. So using the formula, H is equal to ml. In this case, it is LF. Okay? So what is the amount of heat? And by the way, if you want, you check the units. But here the units are okay. Kilograms, joules per kilogram. So we are good. So we shall say H is equal to 2.5 times 330,000. Okay. Get your calculator and press. I'm also going to press with you. 2.5 times 330,000. Okay? What do we get? 825,000. 825,000. And the amount of heat is measured in what? In joules. So that is what you have there. Right. Let's go to activity number 2. A certain solid has a mass of 0.62 kilograms. So this is number 2. Okay? That's number 2. We have been given mass of the solid. So mass of the solid is 0.62 kilograms. Let's go ahead. At its melting point, it absorbs 200,000 joules of heat. So what does it mean? The amount of heat absorbed is 200,000 joules. Some people are getting angry that I'm only using H. Okay, we can also use Q because it doesn't really matter. Let me use Q. Calculate the specific latent heat of the substance. So they want us to get L. And because it is melting point, that means it is LF, latent heat of fusion. So again, you go ahead and state your formula. So using H, okay, Q is equal to MLF. So LF will be equal to Q out of M. I hope that is very easy. And our Q is 200,000. The unit is joules, and M is 0.62 kilograms. So when you work this out, what do you get? Again, we get our calculators. So it is 200,000. Okay, you press it with me. 200,000 divided by 0.62. And what do you get there? My figure here is 322,580.6. But I want to put it to the nearest whole number. So we have 322,581. If I put to the nearest whole number, because this comes here, and the unit is going to be joules, then per what? Per kilogram. My answer is correct to the nearest whole number. Okay, so that gives you the answer there. Correct to the nearest whole number. So I hope you have followed through on that one there. Okay? Right. Now, as we draw to the end of the lesson, I will give you an assignment. But before I give you an assignment, I want every one of you to remember the main objectives of this lesson. What did we plan to learn during the lesson? What we planned to learn during the lesson was being able to define specific latent heat of a substance and being able to give its SI unit. I think we did very well on that. If you remember, specific latent heat is here. We defined it. And we can tell specific latent heat of fusion, specific latent heat of vaporization, just depending on the process of change of state. And also, we were able to derive the formula, H equals ml. Do you remember we derived it here? H equals ml. We also said we can say Q is equal to ml, because Q and H both refer to the amount of heat, which is in joules. Remember that? Another objective that we wanted to succeed in learning during this lesson was, how do we use the formula Q is equal to ml and H is equal to ml, of course the same formula, to solve numerical problems. And that is what we have been doing here. You remember? Where we have been calculating amount of heat and also specific latent heat values. And lastly, you should also remember that every substance has got its own specific latent heat of fusion, melting point, boiling point, and specific latent heat of vaporization. So that is what I wanted us to be able to succeed. And I'm quite very happy because I know people have understood that. Okay? And so before we end, let us look at this assignment. Right. I will read for you some of the numbers here. Part A, differentiate between latent heat and specific latent heat. Okay? Just differentiate that. You think you can do that? Part B, the specific latent heat of fusion of water is 330 joules per gram. Now, express this value in joules per kilogram. To me, it is fantastic. Very nice. I would be smiling if I were you. And then the last part is the specific latent heat of vaporization of mercury is 294 joules for every gram. That is joules per gram. How much heat energy is needed to change 2 kilograms of mercury to gas, of course it means in a liquid form, to gas at its boiling point of 357 degrees Celsius. And so that brings us to the end of this lesson. Once again, I want to thank you so much for being good students. I know you have been attentive, you have been participating in calculations and taking notes. And continue doing that, attending other programs, and reading a lot of physics and other subjects as well. Stay well till we meet again next time. Bye-bye.